IEEE CodeX Sri Lanka session series. IEEE CodeX Sri Lanka is a national initiative under the IEEE Sri Lanka section. Our goal is to build a strong and supportive community of students passionate about competitive programming and problem solving. It's great to see all of you here with us again, whether you've been with us since the awareness session or are joining today for the first time. You are now a part of a growing community. You are now a part of CodeX. I'm Yashoda De Silva, your moderator for today's session, representing the CodeX Sri Lanka team. I'm excited to guide you through another valuable session in your journey towards becoming a better coder. Now, before we dive in, let's quickly revisit what we did in the previous session. Earlier this week, we began our learning journey with the second session of the CodeX series, led by Mr. Apiram Rajamohan. Held on the 9th of July, over 100 enthusiastic undergraduates from across the island joined us once again, proving that our community is growing stronger with every session. We dive deeper into the world of problem solving by exploring theoretical strategies into two-pointers, arrays, and prefix sums, tactical strategies to begin your problem-solving journey confidently, and a highly engaging and interactive session that truly sparked active participation from everyone. It's inspiring to see the momentum we've built together, and we can't wait to carry this energy forward. Before we begin today's session, a quick reminder to everyone. As you all know, certificates of participation will be awarded at the end of the CodeX session series based on attendance and engagement. To support this, please make sure your Zoom name matches the name you used during registration. I repeat, please make sure your Zoom name matches the name you used during registration. This helps us track participation accurately. Thank you for your cooperation. Now, on to today's topic. Tonight will be a hands-on session affiliated to the previous session on two-pointer techniques, arrays, and prefix sums, which are three essential techniques that appear frequently in contests and interviews. Mastering these will give you a major edge in solving problems efficiently. To guide us through today's discussion, we are honored to welcome again Mr. Apiram Rajamohan, a passionate and accomplished competitive programmer with years of experience in algorithmic problem solving. Please join me in welcoming Mr. Apiram Rajamohan to CodeX Sri Lanka once again. We're truly honored to have you with us for your second session at CodeX series, and we're looking forward to an engaging and educational session. Over to you.
Thank you, Yashoda. Hi, everyone. Apiram again. Let me share my screen. Okay. You guys can see my screen, right?
Yes, Mr. Apiram, I can see.
Hi. Okay, nice. Yes. Hi, for newcomers, I'm Apiram Rajamohan. I'm doing competitive programming since 2020 and participated in many competitive programming competitions, won some. Yeah, that's about me. Okay, today, have you tried the questions, the HackerRank contest questions? By the way, people, I requested the organizers to allow mic, like you guys can turn on the mic and speak whenever you want. If you have any doubts, please clear it out. So it would be more engaging and interactive, and it would be fun for me as well. Otherwise, it's boring, you know. Okay. So let's see. By the way, I can see your submissions, leaderboard, and everything. Wow, wow, 3 people got full score. Vibe Spark, S13 underscore SX3, YRCD underscore 27. Congrats, guys. You guys did well. And Chaturavi, Lakata Brew, Dakshayani Raman, and Johanne J. You guys also did a good job. I mean, trying is important. That's the main thing. Keep trying. You guys one day will succeed. Okay, and I saw this. I can access your submission as well. I saw them, and yeah, I saw some pretty good solutions, some different approaches. Yeah, some different approaches, and I'm happy to hear about your approaches as well. Maybe after I discuss my approach, maybe you can discuss your approach as well. You can do that. And I saw some chat GPT answers as well, but I'm not gonna say uh who submitted those, but uh it's for your own benefit. If you submit chat GPT solution, uh it's your wish basically. But like one thing I suggested the organizing committee to uh add explanation with your submission. So maybe from next contest onward, they might implement it. So let's move on. Let's move on to the problems. Okay, let's start from the prefix sum problem. So let me give you a brief idea what is a prefix sum is. So prefix sum means it it will it will, let's say if we say prefix sum of I means it will contain all the sum from 0 to I. That's what prefix sum is. Like it means AR0 plus AR1, AR plus AR2, so on to ARI if you take prefix of I. And how this can be useful? Uh, like if you want to calculate sum between L and R, what you would do in general way, you would traverse from L to R, like you will do a for loop from R, L, L all the way to R and find. But in worst case scenario, you will travel uh n times. Like basically if the L is 0 and R is n, you will like move to n different positions. So it will give a time complexity of O(n). But using prefix sum, what you can do is uh, you can find the answer within a second, like in O1. Like how you can do is, so prefix I will contain no like this, right? So if you want to get sum between L and R, uh, that is strictly simple. Like you can say prefix of R minus prefix of L minus will give the sum between L and R, because prefix of R will contain sum of the elements from 0 to R, and prefix of L minus will contain the sum from 0 to L minus 1. So if you subtract, the remaining will be uh, sum from ARL all the way to AR. So that's a simple introduction about prefix array. Uh, yeah, not only sum, you can use other invertible operations as well, like XOR or subtraction, or power, so multiplication, division if possible. Maybe, yeah. These are some simple different operation you can use in a prefix array. Okay. Okay, let's move on to the problem. So if you have any doubts or if anything not clear, at least put a message in the chat, or you can turn on your audio mic and speak up. So maybe I'll give like 10 seconds for you guys to read the problem, 10 to 20 seconds, and understand what the problem is, because like I saw most of, like here there are like 60 participants, but I don't think for only like I can see only 8 submissions. So maybe go through the problem. Hmm. Hello. Okay, so let's discuss. So what's the problem? Like I'll describe the problem in some simple words. So you're given an array of n elements, and they are and you have they given m operations, and in each operation uh yeah, you had to increase the elements between L and R by D. Like from L to R, you had to increase the element by value D. And they given Q queries. So what they mean is like um, instead of directly applying these M operations, they say like you have to apply only operations between X and Y. For example, here they give 3 operations. Yeah. So, and they said 1 and 2. That means you apply 1 and 2 first and find the result. Then 1 to 3 and find the result likewise. So what you can do is here. So if I see the question for the first time, what I would do is like you can simply see like you can directly apply prefix sums here, because simple adding operation and it's most efficient one. Yes. And but the thing is it's like it's not direct. If you can apply M operations directly, like if they ask you to like do the operation like directly apply D for all the elements between L and R, then you can simply do like I think in the previous session I discussed about the difference array, but uh, mm, I'll give a simple introduction about it too. So what's a different array is like let's say you have element between node to n maybe yeah. Okay, so for range operations, like if they want to, instead of like changing one element's value, if they give you like a segment where you have to change, then you can create another array. You can name whatever you want. I name it as different array, difference array. And let's say if they mention like you have to change, you have to increase all the elements between L and R by value D. What you can actually do is you can add L to D, and you can subtract D from R plus 1 position. So when you like form a prefix array out of it, I mean when you form a prefix array out of this difference array, okay, let me tell you how to form a prefix array. Maybe yeah. So the basic idea to form a prefix array is like it should contain all the elements from 0 to I, right? If you take prefix I, it should contain AR node all the way to ARI. So which you can simply say like prefix I equal to prefix of I minus 1 plus ARI, because prefix of I minus 1 will contain all the elements from 0 to I minus 1. For the ith position, you need ARI as well. So you can simply do that. So this is how you create a prefix array. So let's get back to difference array. So after doing this operation, and if you create a prefix array out of it, you can observe all the element between L and R will get this D value. So if you process the prefix array, if you say for diff I equal to diff I minus 1 plus diff equal to diff I minus 1 plus diff I, then you can see that like all the element between L and R will get this D, but from R plus 1 position it won't get that value D because it's getting subtracted. So using this different array, you can see like for each position how much you have to increment, how much you have to add. That's what the function of this difference array. So if they give the operations directly, like if I ask you to just increase the value between L and R by D, you can use the simple different array and do it. But they made it complex by saying you have to add this from like you given M operations, right? So they given like for each, and they given K queries, and in each query, uh, they say like you have to update the elements from like for the elements in array, you have to use all the operation from L to R. So you have M operations, and for you had to perform K queries, and each query you had to do operations between L and R. How we can do that? Actually, what we can do is we can make another prefix array to store how many times each operation is taking part. So what exactly we can do is yeah. So yeah, if I show the solution, it's too complex. Okay, it's too complex. Yeah. Okay. So okay, we can create first prefix array to store how many times each operation is going to take part. So you have M operations, and for the queries you can like make a prefix array to check like how many times this operation is going to take part, because in each k queries they are going to give L and R, right? L and R, where you have to do all the operations between L and R. So let's say uh, let's make a prefix array of operation prefix, and it will contain how many times I operation need to be taken. So what it means is, if they given L and R, you have to add one to operation L uh, equal to operation prefix, right? Operation prefix L plus 1 and operation prefix of R plus 1 equal to operation prefix of R plus 1 minus 1. We are doing a difference array. So all the operation between L and R will get plus 1. And after that, it won't get plus 1 because like we are subtracting it. Basically, we are doing the difference array here. So after this, we can get how many times the else operation need to be taken in the array values. Now, even though now you get like how many times the operation need to be taken, still you have to find like you have to make the changes to the original array values, right? So for that you need another prefix array to make those changes. So what you can do is make another prefix array, and you know how many times these operations need to be taken. And yeah, so prefix I into the value D. Yes. So for example, the ith operation, let's say the ith operation is L comma R comma D. They given L R comma D. So and the operation prefix I is how many times you have to do the ith operation. So basically you got all the stuff here. You got it. Now you have to like update the original array. So to update the original array, what you can do is again you can use the difference array. Add, you had to make change from L to R, right? So add prefix of L, how many times operation prefix of I into D, then prefix of R plus 1, you have to subtract it, how many times operation prefix of I into D. Then from the prefix array, you got the answer. Like after you form the prefix array, you basically got the difference array. Then if you add for all the elements, like the answer for ith portion is ARI plus prefix I, because this will contain the difference value and this is the original value. Okay. Now let's listen to your feedback. if you don't understand anything, please let me know. So maybe I can explain in a more thorough, simple way. Hello guys, you can unmute yourself or maybe put a message in the chat. Mm. At least put like you got it, Kayla. It's fine. Say something. How many of them are sleeping right now? How many of you are eating right now? Uh, okay, it's clear. Okay, I hope it's clear, but if you guys don't understand it, please send me a message. Okay, thank you. Let's move on to 2 pointers. Okay, let me give you a small introduction about the 2 pointer as well, like a quick summary or quick overview. Okay, so 2 pointers is basically keeping track of 2 points. So you will keep a point somewhere in the array, let's say 1 point equal to L, and you will keep the other pointer somewhere in the array, let's call it R. So by moving these pointer, like maybe let's move this R to the next position, or by moving this L a bit forward. Likewise, by moving like this, you can find some answer. You can solve some problems. What kind of problem you can solve using 2 pointers? So let's say you have a problem where you have to use two for loops, like uh, for I less than plus or for ij, because something like this. Maybe let's say this I. So for most of the uh, two loop problems, here like you are using I and j, right? Instead of this, like we can like make these two as 2 points in the array and solve it for some problems. S- For some problems, you can't, but most of the problems you can. Why it's helpful? Because like I think you guys know the time complexity stuff, but here in the worst case, the I will run for n times and j will run for n times. So the time complexity will be n squared. But if you like, if you remove this like stuff and initiate 2 pointers, like it's L and R, like I said before, if you move like forward and backward, you can see that the L can be at n different positions and R can be at n different positions. So total number of positions the both can be in is n. So total number of positions are n plus n. So, but if you generalize it, like you will, when you uh, get the time complexity, you will remove the constants, right? So if you remove the constants, you will get the overall time complexity. So that's where it's useful. like O n is much smaller than O n squared. If you take like large number of values for n, let's say n is 1 million, so you can think like how big n square will be. So it's better to always optimize problems if you can optimize it. So that's 2-pointer. Let's look at this problem. So for this problem, I saw like 8 submissions. So I'll give you guys like 20 seconds to read this problem and get some idea. Then we'll discuss. Okay, let's see what's the problem is. So they given n songs and each have some positivity AI, and this Misha girls won't at least be satisfaction after hearing song. So she wants to start somewhere and keep like she will like insert it. I mean, she will hear it in a loop, okay, in a loop until she get full satisfaction, until she get happy, and we want to make her happy. So that's our goal. For that, we have to. We got a message. Yeah, nothing. So we want to make Misha happy, and we need to find a starting position where if she start, she can get happy very soon. That's our goal. That's the problem is. But what you can note, like when you solve a problem, after first read the problem statement carefully, understand it thoroughly. That's the first basic thing you have to do. The second important thing, like when you solve a problem, second very, very important thing, check the constraints. Because like by seeing the constraint, you can get an idea like what kind of approach you need to take for this problem, or like what time complexity the problem creator expects from you. So, and maybe you will get some hints, or you will get some additional information what you have to do. All kind of things will be hidden behind this constraint. And here, what you can observe through this constraint is the satisfaction level P is 10 to the power 18. But each song can only provide 10 to the power 9 satisfaction, 10 to the power 9 positivity. So, and there will be n different songs. So even though if she listen in all the n songs, she won't be satisfied sometimes. In worst case scenario, she won't be satisfied. So she will go through again and again and again until she gets satisfied. But uh, but we can directly say, right, So if all the the sum of all the positivity is less than p, then like we again come to the starting position again, right? So if she start from this position, she will listen all the songs and all the way and come here again, and the positivity, I mean, the satisfaction will reduce by the sum of all the n songs. And again, she will continue her move until she gets satisfied. So actually, you can ignore those ignore those rotations by like what you can actually do is, okay, let's say sum is all the sum of positivity, or sum of all the positivity, that is basically AR naught all the way to ARN. Okay, so like you can do maybe a while loop to check while p less than sum, while p greater than or equal, yeah, maybe while p greater than or equal to sum, p minus equal to sum, and you have to note how many rotations she did, rotations plus plus. So rotation is how many rotations she did. But even if you see it, like it will also take some time to complete the while loop, because p is 10 to the power 18 and some the maximum sum we can get is 10 to the power 9 into 1000, which is 10 to the power 13. So 10 to the power 18 divided by 10 to the power 13, you will run it for 10 to the power 5 times, which is okay, but we can do it in very, I mean, in a better way, more efficient way. What you can do is, so instead of doing this, which is equal to, you can just say like rotations equal to p divided by sum, and the remaining p is p modulus the remainder when you divide by sum, modulus equal to sum. So you can do this instead of doing this while loop, but if you want to do the while loop, it's fine, but this one is better. Now you got the rotations and you got the remaining p. So she need more p satisfaction. Now you have to find a starting position so she can find her happiness very soon. Okay, so you have to find, because like if you start at any point after p rotation, you will come at the same point, right? So if you find a starting position, that's okay. Like that's the answer. So you have to find the starting point. Here, where we can use 2 pointers. So we have to find the smallest L and R, which will give you at least some greater, maybe 2, 3m some greater than or equal to P. You have to find a starting position L and the smallest segment which gives some greater than or equal to P. So in general way, like in a basic way, what you can do, you can do 2 for loops maybe. Why? Yes, so if sum from I to j greater than or equal to p, then we check whether this is the minimum we can get or not. Likewise, we can find the answer. What is but like how we can apply 2 pointers here? Like I said before, instead of doing these two loops, you can like create 2 pointers L and R. So you let's say you will initiate L equal to 0, R equal to 0, and what you can do is actually you will move the R to the right until the sum, like from L to R, the sum from L to R greater than or equal to P. If the sum is greater than or equal to P, you check whether it's the minimum we can get, or we just store like we found a L and R which satisfy our condition, which is the sum greater than or equal to P. So we note it down. Again, now the condition is satisfied, but we need to find a smaller segment. So the condition is satisfied. Then we can move the L bit forward. So now condition is satisfied. We can move L forward and see still the condition is satisfied or not. If the condition is satisfied, then again we can take that into account, and whether it's the minimum or previously founded value is the minimum, and we can note it down. And still, if still the condition is satisfied, we can move again the L forward. If the condition is not satisfied, we can move the R forward until R forward until the condition is satisfied. Likewise, you can actually find all the smallest segments that satisfy our condition, because like we are moving the R up until the condition is satisfied, then we are shrinking the L bit forward until the condition is satisfied, and if the condition is not satisfied, then we'll move R again. Likewise, so R will go up to N, and yeah, L will be somewhere here. We checked all the position in the array, and we found all the smallest segments within the array that satisfied our condition, and based on that we can print they asked us to print in the starting position and the number of songs she have to listen. So the minimum of R minus L, the number of songs, and you had output the L. It's pretty simple, right? What do you guys say? Any questions regarding this problem? Any doubts? If you don't understand, please at least put a text in the chat box. Even a personal message, it's fine. Hello. I hope everyone is okay and got this. Sorry. Let's check the second problem. it's bit different, but same as the previous one. Maybe I'll give another 10-20 seconds to read the question, since like only 6 of you attempted this. Sorry. Okay, let's discuss. So what the problem is, they have N1 caps, N2 shirts, N3 pants, N4 shoes, and each cloth element has its color, and you have to find actually 4 colors. Yeah, so you had to choose 4 colors from 4 colors actually, like 1 color from caps, 1 color from shirt, 1 color from pants, 1 color from shoes. So the maximum difference is minimum. So what that mean is, so let's say you have you had to find a set of color 1, color 2, color 3, color 4. Let's say see okay, so maximum of this minus minimum of this has to be minimum. You have to find some colors C1, C2, C3, and C4. Yeah, I have to find that. So it's actually pretty much same as the previous problem, but and I saw different approaches for this problem. Like my approach was completely different, and I saw some good approaches and different approaches as well. For example, this guy used, I don't know, cues, maps, I guess, to do that. I didn't look at most of your, like, I didn't really look at it, but like I saw, like I had a glance, and it's different. Like he sorted as well. Like it's good. It's like it's superb to see so many different approaches. So let me explain my approach. Maybe like at the end of the session, maybe one of you guys who submitted can explain their own solution as well. I give a chance. So what I did was, so they given I checked the constraint, and I noticed like they given the maximum color size can be 10 to the power 5, and they mention it twice. So I got a clue. So there's something have to do with this 10 to the power 5 value. So instead of going through all these N1, N2, N3, N4 clothes, what you can actually do is like you can go through the colors. So you can like find some L and R of colors where you can find all 4 kinds of clothes are available. So basically what it is like, when you solve a 2-pointer kind of problem, you can observe like a similar pattern. So there will be like one loop, like there will be a loop which move, there will be a loop and the R will move forward, maybe some addition or add R. Then there will be a while condition, while not good, remove L. This is the basic pattern, like most common pattern which you can see in a two-pointer kind of problem. There will be a loop and you will add R, and while it's not good, you will remove L. So, and you will keep track of the answer. Keep track of the answer. So this is the basic pattern. So here you will add R. That means like you will add the color R. By adding, like you will create a function. That means when you add a color R, you will check with color R what are the code types available, and like you should maybe create an array or something to keep track what are the clothes are available, like what are the clothes are added. So when you add R, you will like with color R what kind of clothes are available, what kind of clothes are available, and keep track of it. So here there's a function called good, right? What the good function do is it will check whether all the clothes are available. So here you are keeping track, right? So using that, you can check whether all the clothes are available. Maybe if you use array or something, you can like directly check whether all the clothes are available. The remove function does the same as that function, but it removes and keep track of like what kind of clothes are available after removing L. So yeah, after adding R. And here keep track of the answer means like you have to find the minimum different, right? So you have to find the minimum R minus L value. You have to find the minimum. Yes. So it's the pretty much the solution for this problem. Yes. Do anyone not understand this and understood this? If you have any problems, please turn on your mic or put a message in the chat box. And maybe some of you did not submit, right? If you have any other weird or better idea, please turn on your mic and you can explain. Can someone say it's clear or not, at least? Here, it's the thing, like, yeah, it's the thing, like, if you ask questions, like, even though some, I would say stupid questions, it's completely fine because, like, if you ask question, like, I can recall some other stuff I might have noted when solving problems. I can explain to you. Maybe I can give more related ideas to that. So it will be more engaging and more, how to say, better than this. Okay, let's move on to the next problem because we don't have much time. And if you have any problem or doubts or anything, put in the chat. So the last problem I gave. So for this problem also, like I saw some different maybe a similar approach, but like people use DQ mostly. So before I explain this, tell something about the DQ. Maybe I'll tell you something about Q stack DQ. So basically, you know what Q does is Q is like first in, first out. So it's like basic keys queue or petrol queue, uh, kerosene oil queue, whatever. It's basically same queue. If you come first, you will get the first product. So that is what queue does. That's another thing called stack. Stack means last in, first out. It's like your school monitor or school prefect. He comes last and get the get the product first and go. Like he has some privilege or something. So last in, first out. And what DQ is, it's kind of like combined version of stack and queue. Version of stack and queue. But like if you observe it carefully, people don't prefer DQ very much because like uh, the way the DQ, like, if you implement your own DQ structure and if it's efficient, then you can use it. But if you're going to use a standard library DQ, uh, the if you don't know the implementation of DQ, I suggest don't use it because like it's it tend to be slower than other data structures because like it don't have a how to say, maybe it don't have a like continuous allocation of memory. So to find the memory, it takes sometimes it works good, sometimes it uh, takes too much time, too much memory. So maybe if the constraints are too small, use DQ, it's completely fine. If the constraints are big, mm, I won't suggest you to use DQ. But yeah, that's the thing about stack and DQ. Okay, let's move on to this problem. So I'll give another 10-20 seconds for you guys to read. Okay, so the problem is you have to find okay, you have to find a number of different good segments where the maximum, difference between the maximum and the minimum element on the segment is at most k. So what you have to do is sum of all the segments L comma the difference between max and min is k at most k. Yeah. So as previously said, like you can follow the general two-pointer structure. So there will be a loop. There will be add of r. There will be a while loop. Not good. Remove L. Then so here's the thing. If the segment L and R satisfy the condition, you can say you can say okay, yeah, L plus 1 to R will satisfy the condition, or L to R minus will satisfy the condition. Because if the maximum difference between max and the minimum is in the segment L and R is at most k, then it's obvious, right? In the segment L plus 1 to R will also have different at most k, and in the segment from L to R minus will also have the difference at most k. So yes, so here like you can directly get the sum of you can count the sum plus equal to R minus L, the number of segments, if the condition is satisfied, if it's good. Okay, maybe let's say if it's good, if good. Here, okay, now we got a problem. We need a add function. We need a remove function. We need a good function. We have to check whether the segment is good. Okay, and if you check the constraint, the k can be 10 to the power 18, the value can be 10 to the power 18, and n is 10 to the power 5. So two loops won't work. We have to use one loop, so it's obvious two pointers or some advanced data structures, which we'll learn in later session, I guess. But here the n is big, so you can't go for two loops. So two pointers. Okay, you check the constraints. Oh, let's figure out some things. Here you have like if it's like invertible options, like if you have operations like sum, XO, or product, or maybe division, you can directly use it, right? Like you can directly find or even, yeah, if it's something like this, or maybe frequency, you can directly add 10, you can directly remove. Like it won't have much effect, because like if you want to add, you can add the value. If you want to remove, just subtract the value. And here XO is the same. If you want to add, XO the value. If you want to remove, again XO the value. So these operations can be done. But here some different operations like maximum, minimum, or maybe how to say GCD, greatest common divisor, or some function. Let's say they want to do some things, there might be another problem inside. But in this case, uh, you have to keep track of the maximum and the minimum. So that's going to be a problem here. So how we can do? We can okay. Let me give you a simple idea. So let's create a stack, 2 stacks. So okay. So for all the add operations, let's add the values to the second stack. Okay. So we will have like so this is our, let's say, our stack S1, S2, and we'll get the first value and add it. Again, we get the second value, add it. We get the third value, add it. Because like when you add it, the last added value comes to the top. And in stack, I didn't mention, like in stack you can do 2 operations. One is push in stack. You can do 2 operations. One is one push, add actually 3 operations, add to the top, second pop, which removes the top, and third top, which gives the top element. So when you add it, let's say this cone is the top and this is the bottom. So whenever you add it, let's say if you want to add a new element, the element will goes to the top. And if you use a top function, it will give the topmost value. Okay, that's the stack. Okay, so now you created a stack, 2 stacks, S2 and S1. So whenever in add part, you add value to the stack, S2 dot push R means S2 to push R. Okay. And for the remove part, that's the hardest thing. That's why people used DQ, because like in DQ you can push to the top as well, push to the bottom as well, remove from the top as well, remove from the bottom as well. That's why people use DQ. But we can actually work it out using only stacks. It's more simple and most efficient way. So in remove, you have to remove the last value, right? You have to remove the last value. So what you can actually do is, if okay, let's say this is our segment L1, L2, L3, L4, L5. Okay, let's say we have 5 elements between L and R. We can divide this into 2 stacks actually. So S1 stack will contain this stuff. S2 stack contain this stuff. And like, so if you want to remove R, you can remove from here. Okay. And if this thing is empty, actually this is S. It will in this order, right? S1, sorry, S2 and S5. Okay, maybe, yeah. So whenever you add it, let's say you added 4 elements, so 4 elements come as this, and stack S1 is empty right now. So let's say now you have to do the remove operation, remove L. You have to remove the last element here. It's a stack where only you can remove the top element. So what you can actually do is, if the stack 1 is empty, you can put all these elements into stack 1 and you can clear it out. So what you can do is, by if s1.empty while s2.empty, like while not s2.empty, while s2 is not empty, you can put all the element into s2.top, s2.pop. So what happened here is, first it will get like s2 top is x4, it will add x4 here, then it deletes this element. Now the topmost part is x3, so it will add the x3 here and removes the x3. Here you can add, if you pop it, it will remove the x2 and add here. Again, if you do it, it remove this and add here. You can see that it will come in an order where now you can remove the L part here, because the first element here, because it comes to the top. Did you get it? So this is the technique we are going to use it now. So for the remove operation, if S1 is empty, we get all the elements from S2 and have it here, or else we can, like, if it's not empty, then you can see, right, it will be in the order from L, and you can just remove this top part and work on the other element, maybe get stored here. So x6, it might be like something like this. So you can, if you want to remove something, you can remove the x2 here. If after that, if you want to remove x3, x4, after it get empty, you will refill it with those values. X6, x7 will come like this, and this will get empty. S1 but pop. So this is one of the technique where, like, if you have to perform some other operations, uh, other operations, like if you don't want to do some XO or some complex operation, maybe some you have to implement some functions or something like that, you can use this two stack method to solve the two pointers problem. Okay, let's get back to the problem. So here we have to keep track of the maximum and the minimum elements. And these are some functional things, right? You have to find maximum, you have to find minimum, you have to do operations, yeah, other than addition, XO, those things. Therefore, you have to, like, keep track what is the minimum inside the stack S1, what is the minimum inside the stack S2, and what is the maximum inside S1, and what is the maximum inside S2. So how you can do is you can create another maybe like 4 stacks. One is for minimum of S1, minimum of S2, maximum of S1, maximum of S2. So what it does actually is when you add a element to the S2, you just add it to the minimum S2 as well as maximum S2. Like if the stack is empty, then the maximum is ARR, minimum is ARR. If stack is empty, stack if S2 is empty, otherwise else you will store the minimum. Sorry, you will store the minimum, whether it's the minimum or previously in the element, like when you add something, if something is x8, and if you want to add something x9, you have to compare like there's already x8, right? You have to check whether x8 is the minimum or x9 is the minimum. So you can just check like minimum of min of mini2 dot mini s2 dot top of the current element. Similarly for the max as well. Here max. So now like in the minimum stack, we have like in the top we will have the minimum of what S2 have, and in max S2 stack we have a maximum of what S2 stack have, because like if you look at the stack mini S2, it will contain X2, I mean X8. Then here it will contain minimum of X8 comma X9. And if you look at the maxi S2, it will contain max of X8 comma X9 and X8. Likewise. So basically this we will do the same stuff when you like put all the element from S2 to S1. So when you add it, if the S1 is empty, you do this, and if S1 is not empty, you will like keep track whether the previous X5 is the minimum or if you see like stack mini S1 will contain min of X5, X6, X7. Here min of X6, X7, and min of X7. Yes, and same as maximum stack will contain max, max, and max. So in always in the top, you will get the maximum and minimum of all the elements inside the stack. Actually, you don't have to create 4 stacks. Like if you can manage, like if you know how to use pairs or tuples or arrays, like you can actually create a stack like this as well, or maybe array of 3 elements, or if you know vector or whatever, you can create actually like that. So this might not be the simplest implementation. If you know how to use pairs and tuples and all, you can create in a more simple way. But to explain clearly, I use it like this. So you will do the add operation here as well. Like when you put all the elements from S2 to S1, you will do this as well. So at final, you will have 6 stacks like this. So if you want to check whether the segment is good or not, you can just check whether uh, the minimum of this stack and this stack, and like the difference between maximum of this stack and this stack, like the how to say, maximum of maxi s2 comma s3 dot top maxi s1 dot top minus min of mini s2 dot top mini s1 dot top. If it's less than or equal to k, yeah, less than or equal to k, then it's a good segment. So what it does is like maximum, if the difference between maximum of both the stacks and the minimum of both the stack is less than or equal to k, that means it's a good segment. If it's a good segment, you can take count of it. So that's it about this problem. Do you guys have any questions about this? This might be more complex. Please ask if you have any question. Like you can change this problem maybe as GCD equal to 1 or greatest common divisor maybe equal to 5 or something, or else maybe do some other function as well. For example, if you see this problem here, it's different. Like you had to find whether some set inside this segment which will form sum equal to S, or this. If you see this problem, it will check if the greatest common divisor of all the elements in the segment is 1. For these kind of problems, you can actually use the stack method, which is same as this. Like if you will follow these general 2-pointer step, then you will implement the add part, remove part, and good part, whether it's good or not. And here you can decide whether you have to use stack, or if you need to perform any other operations other than minimum maximum. It can be like you can directly like change GCD like this, or function func. Yeah, actually you can generalize this as like this. Yeah, you can do some function from the topmost element and current element and store it, and at final you will check whether the segment is good or not based on the top of the segment, I mean top of the stack. So yeah, that's it. So now your turn, guys. Any problems? Anything not clear? It's time to ask. Good? All good? At least say all good. People. Hello. Okay, great. If someone from the participants, I mean, you can turn on your mic and speak as well. I mean, I won't know who you are. We might not meet in future. So you can say, you can ask. Don't be shy. Um, uh, yeah, thank you. So is it clear? Or and there are some problems in code forces education part as well. Like if you go to code forces edu uh, inside ITMO Academy, you can see list of content. Here you can see 2 pointers, and if you click the practice, there's like 3 section of practice. So there's like 19 problems. You can try those problems as well. Yeah, those problems are good. If you're interested, you can do as well. And I made the contest. It can be accessed for another 7 days. So if you want to implement your solution, go ahead. I encourage you all to implement and see. You might miss some steps in implementation as well. So it's better to try implementing. And please don't use ChatGPT or any AI stuff. Do it your own, even though, I mean, if you try it your own, you will learn quick. If you use ChatGPT, I don't know. Yeah, bug shape. I don't know what shape means. Shape, which part is not clear. Maybe I'll add this link to the chat, so you can try this code versus problems. It's good. Or else like you can go to the code process and you can add you can select 2 pointers and apply. It will show you what 2 pointers kind of problems, and based on, you can sort it based on its difficulty and try it out. You can do that as well, like just like 5, maybe like 400, 500 problems. I don't know. You can try and see. Okay. No one is asking any question, so I think I can conclude it. I hope you guys got everything. If you have any doubts or if anything not clear, you can put it in the group. Thank you. Tamindu? Oh,
Yeah, thank you. Apiram.
can we wind up?
Yeah, sure.
Yeah.
were not only clear, but practical and relevant to our audience. And your passion for teaching was truly evident throughout the session. And we're grateful to have had you with us. And we're confident that today's participants are walking away with stronger problem-solving foundations. On behalf of the IEEE CodeX Sri Lanka team, we'd like to present you with this token of appreciation. Thank you for being a valuable part of our journey and for investing your time and expertise into developing
Thank you.
the next generation of programmers. Looking ahead, we've got other sessions coming up, and we'll keep you informed about the dates through our communication channels. These sessions will build directly on what we've learned so far and include hands-on experience to be announced in due course. If you haven't registered yet for the IEEE CodeX Sri Lanka session series, head over to our official website where you can learn more about the competition, track your progress, and get to know session updates. Scan the QR code now, shown on the screen, and register yourself to get full access in the IEEE CodeX Sri Lanka official website. You can join our WhatsApp and Discord groups where you can receive important updates and stay in touch with other participants. Our QR codes are now on the screen, so feel free to scan and join. And with that, we conclude today's session. Thank you for joining us and actively being a part of this. And each session takes you one step closer to becoming the confident problem solver you want to be. We hope you found today's discussion both practical and inspiring, and we'll see you soon again in upcoming sessions. And we continue to unlock new techniques together. Until then, stay curious, stay consistent, and keep challenging yourself. Good night, everyone, and thank you once again.